today, we're going to continue reviewing for the test. As in the informational email I sent out, the test will be sent to you when you are ready to take it through email it to you through a document. It is up to you to tell me when you are ready to take it, and then I will send the assignment to you. You'll have an amount of time to complete it from there. If you feel ready for it, you could take it today, but you can take it anytime through next Monday. Just make sure you set aside a time where you have a nice quiet space, comfortable, you're able to do everything you do, you have the calculator on the sheet, and that you have a length of uninterrupted time that you take the test. It's designed to take you 1 hour. I'm giving you 5 hours because of reasons like academic foundations and also the fact that it takes longer to answer your questions through email, and additionally, I know this thing there come up and you go to the bathroom, have to go eat, etc. So this is all summarized in the email I sent. So today I will open the floor up to any questions you guys have about the test, about chapters 1 through 4, about particular assignments, particular types of questions. Before I open the floor up to any sort of questions you have, though, there are a couple of specific things I'd like to go ahead and show you. Not really content, but more about information that is now on the Brightspace page. Oh, geez. Thank you. Okay. So, when you enter the Brightspace, come on. When you log into the Brightspace page, you have many tabs here. I have more than you because this is the teacher view. You got intro, chapter 1, so on and so forth. In the Test 1 tab, which is just after the chapter 4 tab, we have the formula sheet that you can use for the test. This is admittedly an old, poorly formatted version, and I am currently making a much better formatted one, which will be put here for you to use. So this is every formula we've covered so far. It's everything that you will need, and you can use it for any and all assignments. The updated copy will be put right here in place of this one. I will also probably send out an email with it attached. Beneath that is the practice questions that I emailed everybody. Again, these are just practice questions if you want to do these as a part of your studying. They are similar in, say, difficulty and length to the test questions. And as you are doing these, there is uploaded beneath that an answer key to those questions, which the scanner rotated. I'll suppose this will fix it here. Well, I'll work on it later. But these are the answers to the practice questions in here, so that when you're working on them, you can check the answers yourself. If you got it right, wonderful. If you have any questions about any of them, you can ask those at any time. This study guide that I made, these practice questions, are, again, similar in length and difficulty and content to what would be on the test. I tend to overshoot and make the practice questions longer and probably a little bit harder, just to help you in your studying than the test will end up being. Additionally, on the test, there'll be probably about 110 points worth of questions. All of my questions will say next to them how many points each one is worth. So a short free response question might be worth 5 points. A long multi-part algebra question might be worth 15 or 20 points. There's 110 points worth of questions, and you will be graded out of 100 points. And if you got everything completely right, you can get a 110. If you missed 10 points worth of things, you'd still have 100 out of 100. I do this to give you a chance at bonus points. I used to have a system where I would have like 6 questions. You only have to answer 5 of them. Any effort into a 6th would be bonus points. But that system sort of requires every question to be worth the same amount of points. And that was restrictive to where I had to ask really long, convoluted questions the entire test. So this way of doing it was just more points than 100. It'll free up which question or questions are the bonus questions for you. I do recommend still answering everything, because anything that you write is better than nothing. If there's a question that you just don't understand or you didn't have time to get to, again, any answer is worth more points than blank. I recommend writing physics equations, but if you're honestly can't even think of any related ones, again, write a meme, song lyrics, the script of the B movie, whatever you want. So if you want, this is very good practice if you want new questions to do as part of your studying. You guys, the answers are here. We can talk about these questions here today if you've begun working on them and you just want to go through them.
You say the practice questions are harder than the actual test questions.
I default to making these ones harder than the test, because this one you have as much time as you want, you can look at the answer. The test is designed to be done in a fixed amount of time, so I would rather that one I'd rather of the two of them, this be the trickier one. Because this you have time to study and look things up and check the answers. And that way it covers every single possible thing and difficulty level that could be on the test. So if you can do this, you'll be fine. My purpose with you guys in this class is not to trick you. I don't want to make this an incredibly difficult, unfortunate experience. I know that a lot of people go into physics terrified, because it is admittedly a hard science, both in the literal sense that it is classified with hard sciences, but it's also a difficult class. I don't want this to be an experience that you dislike, because I actually wrote a paper on if you don't like the class, you're not going to learn very well in it. So I'm trying, my policy is always to default to making things better for you guys, because if I can improve your experience, you'll learn better. So I try to give you as much information as possible and try to make things as straightforward as I can. Because I want you guys to learn this material well, because even if you never take another science class again as long as you live, the world you live in still runs on the laws of physics as we understand them. So I want you to at least remember some of this stuff. So, I guess that's my little soapbox speech for today. All of this information is here. The updated formula sheet will go here as well. I'll email that out to you just so that everyone has it in their inbox. And again, our entire purpose for today, I'm not going to give you anything new, because I just want you to focus on the test for right now. We're just going to be I will answer any questions you have about chapters 1 through 4. So, I'll now open it up to you. First of all, hello again. I do hope you guys are having a nice day. Let's see, weekend's nearly here. There is no lab today again. But if you want to come in for study time and questions, I will be in here, but you do not have to attend if you want to take that time to study or math or take the test. Yes?
So
is this class format today also going to apply tomorrow?
Sorry, one more time.
So is this class format today where we're just kind of like, just kind of a Q&A session? Is it also going to be like this tomorrow?
Yes, it is. And
Okay.
in the informational email I sent out earlier this week, I did try to, I might have worded it poorly. This week is entirely review. And if you feel comfortable, then I won't require you to be in this room, given all of our guidelines at the moment. I'm not going to ask you to come to a place if you don't need to be there. So if you do not feel the need to come in and ask study questions, you do not have to attend lecture for the rest of this calendar week. Next week, we'll be going back over the test. I'll be giving you the test back and also starting chapter 5. So next week is normal. This week, the test week, if you don't feel the need to review with me in person, you don't need to come to the room. That said, if you feel completely justified in leaving right now because of that information and you're fine, you may. I will not stop you. If anyone needs to head out or just wants to head out, you can now. But if you wish for any study information at all, you're welcome to stay. Thank you for asking. And any more policy scheduling questions? Before we move into content. All right, so any inquiries at all about any of the content that will be on the test? Additionally, if you weren't aware, and if you click on the Test 1 tab itself, there's the instructions about how the test will work, and there's also a list of topics here. So this is all the stuff that will be represented on the test. It's the things from chapter 1 through 4. It's just written in a list because I find that does help me study at least. I can look at that. I can look at the tagline. I can review the formulas relevant to it as I go down the list. If no one has anything specific in mind, we can just go down this list and refresh ourselves. But is there anything? I'm prone to just going through the list in whole so that we can talk about everything from the beginning to the end again. But is there anything you guys have before or in place of that you'd like to focus on instead? Yes.
How many questions are there for each topic?
I have, admittedly, there's a lot of items listed here because, especially in the beginning, we spent like 2 weeks on chapter 1, which was like all of this stuff because it was laying the groundwork. I would say, I didn't pull up the actual document. Because some of the questions tend to combine multiple chapters into one question. Pretty much everything is represented in some form, but there might not be one big multi-part question dedicated entirely to torque. Torque might be part of a larger question. It's just one thing mentioned, like in this system, like list these 5 things about the system, one of them being torque. And if a question is longer, it is worth more points, and you can get points even if you don't answer every single part of the question. If you just are blanking on torque, you just don't answer that part of the question, you will still get points for every other part of the question you answer. I got myself sidetracked again. There's the test file, which you guys won't see on screen.
And also like how many questions on the test?
Right, that is what I'm looking it up. That is why I am loading it, because while I have calculated all the points on it, I myself don't remember that number. 3, 4, 5, 10. There are 10 total questions, all of varying length. So, and they're not in any particular order, the way that I wrote them. So you might start with a 5-point question, then move on to a 20-point question about multiple things from all over the period so far, and back to a 10-point question.
So by length, do you mean in parts? Like one that have questions that are, subset A, B, C?
Right.
Okay.
Questions that have more parts tend to be worth more points, but there is one particular question, the one that is worth the most points, asks you a single thing, and it's just a tricky thing to find.
Yeah.
So all of the topics are going to be kind of mixed in together. They'll all be represented somehow, but usually like similar things will be lumped into one question. Like, there might be a question about work that also asks you, what is the kinetic energy that this object possesses during this time, or what is the heat it has at the end. Again, the practice questions are good samples of this. That up. All right, so yes, this is again the practice questions, question number 4. This is a very good example because this ties in multiple things in one. So we have a car driving on some velocity. It has this mass. The engine is exerting this force forwards. You were asked net force on the car, identifying all the forces on the car, finding the kinetic energy that the car possesses while it is at this velocity. So unrelated to the first 2 questions, but something you can calculate with the values that you've been given. Coefficient of kinetic friction. You can again go back to looking at all of the forces, comparing them in the friction formula. And then lastly, the power output. Again, something you can find using these values about this particular car. So this is a good example of how everything kind of ties into each other. And, okay, 3 is just a projectile motion question. Centripetal, linear versus angular. This is about 7 is about work and GPE. 8 is collisions. 9 is impulse, and then some miscellaneous concept questions just to help you review the concepts involved. The answer key has answers to all of these, but because my handwriting is terrible, I typed out the short answer questions to make them easier to read. Granted, the screen is pixelated and everything's rotated and small, but on your screen it should be perfectly fine. Let's see if I can actually fix the fact that it's installed. Okay. Any other questions about the test itself, I guess? Okay. Anything from chapter 1 through 4 that you'd like us to focus on? Any questions at all about just something that you found in study or you just haven't understood? I know the rotational stuff we just did is already kind of a brain twist.
Actually, yeah, hold on, let me pull up the lab real quick, because there was something on there.
Pardon me.
So I don't know if there's any question like 3C on the test. If it's the object accelerating, it's finding the moment of inertia, an object accelerating angularly at 15 radians per second squared.
This might count as spoilers, but I don't want to psych you out and make you worry about something that isn't going to be here. So. Okay. I don't want to give too much away, but if it helps set your guys' mind at ease, there is no question on the test that involves the concept of moment of inertia. I don't want you to end up panicking over it and studying it and then it not being there. So, for you guys' benefit, there's no moment of inertia question. None of the formulas involved required of you to use. It'll still be on the formula sheet because it needs to be there for moving forward, but this won't be a question related to it. It is, I admit, it's the weirdest thing we did in the last week. And that's saying a lot because rotation is already kind of weird. So I don't want to focus on it. I only brought it up because it's in the formulas and it's a concept that is worth knowing. But since it's the strangest and newest and weirdest one, I'm not going to count it on the test. Anything else? Okay. Again, you can send me your questions at absolutely any time. I would like to just go through this list with you guys, remind you of everything that we did, remind you what all of these things on this list mean, so as just to help refresh your memories, because there's some stuff here that we probably haven't talked about for a week or two. So, this list just summarizes everything from the beginning of chapter 1 till now. As such, we start at the very beginning with conversions and metric units. We've been doing these the entire time. That said, I have seen some issues when converting radians per second into revolutions per minute. So if I could at least put a conversion like that up on the board now. Let's say that the problem says something rotates at 30 radians per second. This is again an angular velocity, which is the omega, angular velocity. It tells you how fast something is rotating. Radians are analogous to angles. It just tells you how much it rotated in a specific amount of time. 30 radians per second is actually really fast. Now, rotations per minute is just a different unit of angular velocity. It measures the same thing. It's like the difference between meters per second and miles per hour, or the difference between newtons and pounds. It measures the same thing. It's just a different unit for it, so we can convert from one to the other. So, looking at our units at the top, we have radians, we want rotations. How many radians are in a single full rotation of an object? Research finish. 2 pi, very good. So, we want radians to be canceled and left with rotations on the top. To cancel radians, we will put 2 pi rad on the bottom and 1 rotation on the top. So this is just our conversion factor. If you haven't got it written in your notes, 2 pi radians is 1 full rotation or revolution. I use those 2 words synonymously. You can also define that as 360 degrees. This is just one long equality equation, one long conversion factor. I already can't talk today. Nowadays, just making it first year. For some reason, people have fallen out of having them flare up recently. They have no good reason as to why. Just 2020, I guess.
Yeah, I'm in the same group.
Just wish you well, along with anyone else who's currently snifflier than they should be in the fall.
It's killing me.
Sorry?
I say, it's killing me.
Oh no, I'm terribly sorry. I've been to start taking twice my normal allergy dose.
I think there was a report that said that this pollen season is significantly higher than any other.
How much is building, shouldn't it? Or do trees just give off some of the
Or this
fall?
allergy season.
There's like, there's
Okay.
types of plants that bloom in the fall, and then there's also other stuff, like types of molds and grasses that, as it starts to get colder, start coming out and cause allergies.
Sorry about this tangent, but thank you for that information. Okay, back to physics. So this is just our conversion. They're all equal to each other, so we're just multiplying by 1 here, basically. This will cancel radians and leave us with rotations. Now we need to cancel seconds and leave them minutes. There's 60 seconds in 1 minute. Cancel seconds, leave us with minutes. And so to go from radians per second to rotations per minute, you will multiply by 60 and divide by 2 pi. The reverse is true if you are going from rotations per minute to radians per second. And as a result, we will get a very large number, something to the effect of 900 divided by pi. I'll actually do that operator in my head.
How does my calculator always end up at the very bottom, even though it's the last thing I put back here?
So the final answer, just if you want it in your notes, is 286.48 RPM, which is a lot. It's a lot of times to rotate in 60 seconds. You can. I try to write it like this on the board so that you can see what the unit is made of and how you would need to cross multiply to cancel things. But this is rotations per minute, the same RPM as the meter in your car. So we've been converting all semester. That's just a particular conversion I've seen be tricky recently. Then we talked about displacement, velocity, and acceleration. We've sort of been reviewing those in the recent chapter because we've been comparing them to their angular counterparts. So sort of in the order we went, this is the linear displacement, velocity, and acceleration, represented by the quartet of formulas from the beginning, which, again, the sheet has them listed as the Fantastic Four because they are very important to everything we do. And those formulas just define how these things are related. Then scalars versus vectors. A vector has a direction, a scalar doesn't. One-dimensional and two-dimensional motion. 1D is just back and forth in a single axis, as most of our examples. But projectile motion is an example of 2D motion, because if something is falling in free fall, and I don't define it up here, but the state of free fall is when only gravity is accelerating an object, exerting force on an object. For a projectile type question, an object can be moving up and over at the same time. That's 2 dimensions at once. And since I've gotten a few questions about how that kind of question on the practice test, there is a projectile practice question. I would just like to refresh your memory as to the starting points, how you begin to tackle those. Most of our projectile questions begin with something being launched horizontally from a high place. I've used examples of a car, a remote control car, being remotely driven off of a cliff for a movie stunt. I always have to be very careful with taking the examples. But we've also, fired a pumpkin cannon off of a cliff, things like that, kicked a soccer ball. And the way to begin these questions is, since this is two-dimensional motion, you need to track what's happening in both dimensions. That is, the x and the y. So, for each dimension, you need to look at where the object is in each axis as time passes. So your starting point should be setting up the same equation twice, once for each axis. Now, in general, which of these two axes determines the hang time, the amount of time an object is in the air? The y-axis, very good. Since everything in free fall is always going to accelerate at the same rate on Earth, the only thing that increases the time you have in the air is the height you are dropped from, as long as you are not being thrown up or down. If you are being launched horizontally, your initial velocity is 0. So I will actually simplify this by one line. And so your height will determine the time in the air. That time is all the time you have to move horizontally away from the cliff. You're always launched at some starting velocity. That starting velocity says in 1 second I will travel 40 meters. So, looking at the x-axis now, is there any acceleration in the x-axis? No. If it's in free fall, the only thing making accelerate is gravity. Gravity is entirely vertical. That means that the x acceleration is 0. We can simplify this to just x displacement equals vix times time. Vertical always determines the time in the air, but the horizontal velocity will tell you how far you go in that amount of time. From the same cliff, like if multiple people are lined up on this cliff kicking the same soccer ball horizontally, whichever soccer ball goes horizontally fastest will go the furthest because it can cover more distance in the amount of time it has to fall. So for all projectile motion questions, you track each axis separately. The y-axis determines hang time, the x-axis determines how far it goes in that amount of hang time. Next two things on this list are very connected. We have force and Newton's laws. Force is what makes masses accelerate, and that is summarized in Newton's second law. Let's see. Actually now going to pull up the answer key to the practice questions, because one of the practice questions I asked is what are Newton's 3 laws of motion? First law, an object will remain at rest or at constant velocity until acted upon by an outside force. This is the law of inertia. Everything with mass has inertia, which is just secretly telling it keep doing what you're doing forever. This is the reason why the objects on my desk will stay stationary until I come in and manipulate them. It's why things flying through the void of space will keep flying through the void of space until they hit something. Next, second law of motion is just the formula for force. Force equals mass times acceleration. This is a very important formula. It is on your formula sheet. defines what force does, at the very least. And then law 3 is the action-reaction pair law. When you act on something, it will act back on you in the opposite direction with the same amount of force. Every single action-reaction pair is always a complete opposite of one another, and they always act on different objects. If I push on a board pushes on me, each force is on a different person there. That is why normal force and gravity are not action-reaction pairs. Among other reasons, both the gravity on this cart and also the normal force on this cart are acting on the same thing. So they cannot be reverses of one another. So, force is a push or pull that makes a mass accelerate. These are these laws. You have work and power. When you do work, you are using energy to accomplish a task. You are exerting a force and making something move a distance while that force is being exerted. Work measures the energy used in such a task. So we measure it in joules. It just tells you how much energy you spend to do this thing. Power is the rate at which work is done. You take work and you divide it by time. It tells you how powerful you are, how much energy was used in a period of time as opposed to overall. The more power you can output, the more energy you use per amount of time. You can get more done, but you will also use up more energy faster. Then energy itself. There's lots of different forms of energy. Energy is just a thing that matter can possess. You can't see the energy itself, we can only see what matter does when it has energy. It also cannot be destroyed. It simply transfers between different objects in different forms. You can transform energy, but you cannot destroy energy. Two forms we covered are kinetic, which is the energy of motion, and gravitational potential, which is energy stored in an object's ability to be falling. These two types of energies can convert back and forth from one to the other. When I throw something vertically upwards, I give it an amount of kinetic energy initially. It has a velocity. But what happens to that kinetic energy as the marker rises? Very good. As it rises, it's going to slow down, right? Its velocity will decrease or become more negative until it eventually just stops at its apex. Once it has stopped, its kinetic energy is now 0. But at that maximum point, it's now at its highest, and now all that energy has become GPE. The reverse then happens on the way back down. The GPE becomes KE as it gets faster and faster until it gets its lowest possible height, its highest possible speed. Any questions so far about anything you do there?
Say GPE goes when you're positive, right?
As if you were talking about the GPE an object has because it is above some point, yes, that would be positive. If you recall the formula for GPE, my board is a mess right now. The formula for GPE is mgh, and both this and the kinetic energy formula don't really care about the direction of the variables you plug in. Energy is not a vector, meaning you cannot have backwards energy. You cannot have energy east. So whatever directions on this velocity goes away, you only have a positive amount of kinetic energy. Similarly, this formula doesn't care about the negative on the 9.8 because it doesn't care about the direction, it just cares, this times mass tells you the force, and that force is exerted over this height. There is one way to get a negative GPE though, and that is when your ground point is above your object. If I dug a big pit outside and I threw something in the pit, compared to the bottom of the pit, the object I throw in would have a GPE of 0. But if I compare it to the ground level above, it would have a negative GPE because it's below that point. It lost even more energy than it had to get lower. And I would have to give it more GPE to get it back up to this height. So you can have a negative GPE, but it has to come from the H, not the G. This is sort of, KE is absolute. It depends on how fast something's moving. GPE is relative because it depends on what you define your height as. If we're just looking at me, if our baseline is the ground, I am on the ground, I have no GPE. But if our baseline is the center of the earth, I have a lot of GPE. I could be falling very far through the earth right now, but I'm not because there's something holding me up. This is entirely about your frame of reference. I will always tell you your frame of reference, but it's worth knowing. After energy, we talked about momentum and impulse. Momentum is kind of similar to kinetic energy in that it's a thing that matter possesses when it is moving. But unlike energy, it only has one form, and since it cannot transform, it will be conserved in every single type of collision because there's no other state it can occupy. Kinetic energy can lose to heat, to noise, to deforming your car's bumper, but momentum must remain. Because there's nothing else it can do. Impulse, is simply defined as the change in momentum. If a mass changes velocity, momentum changes, it undergoes an impulse. Then we started our discussion of, you know what, this list is a little bit out of order, my apologies. After momentum, we covered gravity. First collisions, two types, elastic and inelastic. Then gravity, universal law of gravitation, because gravity between literally everything, depending on the two masses and how far apart they are. Then everything we talked about during rotation. You know what? I don't want to psych you out and make you worry about it if it isn't there. I didn't ask a rotational momentum question either. So you can mentally strike that from this list. You do need to know like the basics of rotational motion, comparing linear displacement velocity acceleration to angular displacement velocity acceleration. And you do need to know what torque is. Because even if you never talk about angular momentum again, you will at least be opening doors and observing seesaws and crowbars and baseball. You should know what torque is. And that is everything we've covered so far. And I have told you a couple of things that won't be on the test because I hate tricking you guys. I also hate allergies. Any questions about anything that will be on this test? You will also have your revised formula sheet. Every formula related to these concepts will be there. I will even try to label them based on section. Yes?
That's what I was going to ask, if they're going to be ready.
Yes, I realize that that does help people like, hone in on where they need to go on the sheet. So I will try to make it nice and evenly formatted where everything is the same size and it's sorted based on the content. We're nearing the end of lecture anyway, so if you have any questions at all, you are welcome to come around. You're also welcome to come during what would be lab time today, but you do not have to. You can study on your own or begin the test today if you wish. You do have to take the test before midnight on Monday, so that when Tuesday lecture starts, we can talk about it. So the last day you can take the test is by the end of Monday. So if you start your test at 7 p.m. Monday night, you should be done by midnight. That was, shoot. Hold on a second. Every time I lose my train of thought, it just vanishes. How do you lose a train? That's a bad thought. I'm distracting myself over there. As a reminder, tests as a whole will make up 40% of the grade in this class, but there's two tests. There's two tests, and then there's going to be one exam in a separate category. So the two tests will make up 40% of your grade, which means that each single test is about 20% of your grade. That means if you got a complete 0, you can still get an 80 in this class. But more realistically, as long as you at least try every question and put, like, at least list a formula and at least begin each question, you'll probably, like, at a minimum, you could probably, if you were not even trying, you could get a 50 on this test by just putting formulas in front. And that 50 means that you could still do, if you've got a 50 on this test, you can still get a 90 in this class. I'm telling you this to remind you, don't panic. Everything's going to be fine. We can all do this. I appreciate you. I will help you every step of the way. And have a wonderful day.